Hello, happy snow day. So let's just talk about the things that we would have done tonight, real quick, if there wasn't such a big snowstorm out there. So today you're submitting the moon phases gizmo. Maybe you already have, and then this is what we would talk about. Are you able to now describe to someone why we see the phases of the moon? If we were actually in class together, I would always suggest this. It's easy to say because your answer for the moon phases could simply be something about. It's really geometry, right? Like the angle that we're viewing the illuminated portion of the moon from, depending where the moon is in relation to the Earth, the sun. Okay, um, so you can say something like that, but it's another thing to model it. So I would say grab these things and do a little model, right? And what we'd end up doing in class is actually taking a little thing like this, a little moon on a stick. Everybody would have one, and we'd stand in a circle with a light hanging in the center to represent the sun. Your head would be the earth. And then you take this, say that's the sun, and then you move this around your head. And if there's no other light in the room, then you can see all the phases quite well, and it makes it very obvious. It's a great way to view it because you're inside the model, right? Rather than just looking at a pie plate of moon phases and trying to understand, you actually see all the phases from the same location that we do from the Earth. Okay, so that's what it is. We'll just kind of go quickly through this. It's we see all the phases because of where the moon is in relation to us. So we look at. So let's talk about these first. Um, Half of the moon is always illuminated. There's always some misnomers about the moon are that there's a dark side and light side. They always change. Sometimes we see the dark side, sometimes we see the light side of the moon. Okay, half of it's always illuminated. So there's not a permanent dark side. There's a permanent far side and a permanent near side. There's always the entirety of our lives here on Earth. We'll always look at the same side of the moon. Always. Those craters that you see, you'll always see that exact same pattern. The same side is always facing us. And that's because you might think the moon doesn't rotate, but it actually rotates at the exact same speed that it revolves. So you can easily demonstrate this with your hand going around your head. So the palm of your hand is the face of the moon that we always see, and as it rotates, sorry, see, I made a mistake there. As it revolves around your head, it's rotating at the same speed that it revolves. If it wasn't rotating, then palm, let me do this hand, your palm would always be facing the same direction, right? Facing the back wall there. Okay. So now it's facing the back wall. When I get over here, it's facing that wall, and so on the way around. So one revolution, and it rotates one time. Same thing the moon is doing. It's in the tidal log. So we always see the same side. Half of the moon is always illuminated by the sun. Always. Half of everything in space is illuminated. And then depending on the angle that we look at them, we see a different portion of that illuminated side. So here, the half that we're looking at, less than half is illuminated, so we'll call it a crescent. In this, the gibbous, more than half of the side that we're looking at is illuminated, so we'll call it a gibbous. Make sense? Crescent, gibbous, and then waxing and waning. So if the right side is illuminated, it's a waxing phase. If the left side or the right side is dark, it's a waning phase, or the left side is illuminated. And so you can see this is in chronological order going from left to right. So as we go across there from left to right, the illuminated portion increases across the face of the moon from the right to the left. And then waning is the opposite. The darkened portion increases across the face of the moon from the right to the left. So those are chronological, going from left to right. So when I'm saying right to left, I'm talking about on the face of the moon increasing. You can actually see that if you do this little thing, if you get a lamp, put it in your room, you can hold anything up, fist, whatever probably, and just go like that. And you'll see all the waxing phases. You'll see it increasing illumination from the right across the face. And then from back here, where it's a full moon, and then as you go this way, it'll be the waning phases. It'll get darker on the right side until you get to the new moon, which is we are looking at the dark side of the moon. Okay, we would use this in class. The important thing is to kind of know the orientation of the where the moon is for each phase. The moon, sun, earth. Okay, so the sun is off to the right here. So obviously the moon is only present in any one of those positions. Okay, so there's the phases. Okay, so the full moon is here. So now the sun is off to the left. So that's important. Don't just memorize this as a picture. You should know them in order, and it'll change depending on which side the sun is on. Okay, so the sun's on the right. So the new moon is always between the sun and the earth. Okay, counterclockwise. That's why we go to the left around your head. And we see all the phases. So any one phase will be present for 2 or 3 days. So that means we rotate 2 or 3 times while the first quarter moon is sitting right there. So we'll see the first quarter moon 2 or 3 times in that, roughly somewhere in that area as it's transversing over to the west. Okay, that's why. So really, the first quarter, third quarter, new and full have exact times when they are at those positions, and then really everything is a version of the other ones, right? Past the first quarter, and it's sort of a gibbous now. Okay. Other important thing to note here on this is the times of the Earth. So time is based on your location on the planet. When you're at your location facing the sun, that is noon. The location opposite the sun is midnight. So all that happens is you exist on this planet and you rotate around as the Earth does, and you just hit all these times. So there's noon, and then when you get here, it's 6 p.m. And you can notice roughly at 6 p.m. Here, let's go back. Noon is when the sun is highest in the sky. For us, we look to the south, and it's at its highest point. That'll come up more in the seasons. But then you get up here, and you're looking back this direction, and it appears as if the sun is setting, and that's just because, obviously, we're rotating away from the sun. And then we're looking directly away from the sun, and it's midnight. And then here, now we can look on the horizon, and it appears that the sun is rising, and we're just rotating towards it. We rotate more under the sun, it'll get higher in the sky till it's noon. So time is simply based on your location on the planet relative to the sun. Okay? So you should now hopefully understand what the phases are, right? It's just about the location of the moon from where we view it from the Earth. So what we want to talk about now be a little more complicated to do it this way, but I think if you think real hard, it'll work fine. There's certain phases that you're not going to see at certain times. Normally, what we would do in class is you'd have to go out and view the moon over the week, and usually people come back with more questions than answers because it's sometimes hard to locate the moon. And what people don't realize is that the moon, every single scary movie and Scooby-Doo cartoon will have you believe that the moon is a nighttime object, right? That's how they set the spooky mood all the time. The full moon comes up. It's creepy, but the moon is actually visible in the daytime equally as much as it is at night over the course of the month, right? For instance, the new moon is only visible during the daytime. So check this out for a second here. New moon, if the moon is in this position right here, at noon, it's going to be at its highest point. 3, it's still up. 6, it looks like the new moon is setting. Ignore all the other 7 locations. Talking about the new moon. But if you're on this side of the Earth, right, from 6 p.m. to 6 a.m., you will never see the new moon because you can't look through the Earth, right? Midnight is the obvious one. On this side of the planet, the moon is there. You're not going to be able to see it, right? You could say the same about any given phase. First quarter moon, if it's 6 a.m., there's no way you're seeing the first quarter moon. Even 9 a.m., or 3 a.m., you're on the wrong side of the planet. You have to wait until we rotate around, and then you'll see the first quarter moon. And in fact, what we can do, this is, we can understand, this is what we're doing right now, is understanding how or when every phase rises and sets. So let's take the first quarter moon, we draw a line straight down through it, perpendicular to that, okay? So that line that we just made perpendicular, right, the other side of the planet from the first quarter, you're not going to see the moon anywhere over here, right? So let's say the moon is in that position, and it's 3 o'clock in the morning, and you're sleeping, obviously. But you wake up and you look outside. You're looking out this way. There's no moon because it's over there. 6 a.m., still no moon. 9 a.m., you look out, still no moon. Noon at this perpendicular line, right? Now you look out and it looks like the first quarter moon is rising, higher in the sky at 3. 6 p.m., it's at its highest point. 9 a.m., it's getting lower. Midnight, it's setting. So we could say the first quarter moon rises at noon, hits its highest point at 6 p.m., sets at midnight. Of course, our times are all, roughly, we're saying it's 12-hour shift exactly. And depending on the season, your location, there's lots of variability to that. So we're just going to keep it simple and go with that. So it's give or take a little bit, right? Okay. So you can do that with any phase, and you can figure out when the moon's going to rise and when it's going to set and when it's at its highest point. Here's a good little moon phase animation. So you can watch this if you're not clear on the moon phases. You can see, here we go, these are the waning phases happening. So the sun is obviously off to the left here. Everything is half illuminated, Earth and moon both, everything in space is. So it's just all about where the moon is in relation to our view. Okay, so that's in the PowerPoint. You can watch that more if you want to watch that. Here's what we're talking about here. So this little critical thinking thing is in the OneNote, so you can just look through, answer this. This is what we would do in class. Go through these, try to answer these. Okay. I think I did this here. So if we were in class, I would do this. I'd say, okay, it's the new moon. Let's cover up the side of the Earth that can't see the new moon. Okay, so you cover that up. And you can even do this. You can do that perpendicular line I was talking about, right? So this is its highest point. Keep in mind we rotate counterclockwise. So this is when up here, okay, see this 6 a.m. is when the new moon rises, highest at noon, sets at 6 p.m. Okay, so the sun is off to the left. Everything would switch if the sun was above it, and the new moon would be up here, but everything would be in the same order then. Okay, so you can cover it with a piece of paper or your hand, or you can just think of this perpendicular line. Whatever you want to think. You can even think the opposite, right? Midnight is where you're not going to see it. Noon is the highest point. It's a 12-hour, 6-hour in between there. Whatever. 6 a.m. to 6 p.m. is the rise and set. Okay, so look over those questions. Try to figure them out. They're the answers. So what we can do is, if you look these over and these don't make sense, you have them next week. We're supposed to not meet, but it's optional if you want to talk about the season. So if you want to come in, we can have questions about this. We can certainly go over that. So lastly, there's also a note-taking sheet in there about the eclipses. We should mention them because they're line up with the phases perfectly. So here, if the moon, as the moon orbits the Earth and it blocks out the sun, we call that a solar eclipse, right? It's eclipsing the sun. So this is a solar eclipse. If you want to label these. Sunlight, we've got the umbra and the penumbra, and then here's where the total solar eclipse is. So the solar eclipse has to happen, as we can see, during a new moon, right? So it happens in the middle of the day, rarely happen. Our scale is way off. Normally the moon is a little bit above or below the sun, right? It's not exactly in line. So they're a rarity, especially for specific locations. And the lunar eclipse is when the moon is on the other side and passes through the Earth's shadow, which happens a lot more often because the Earth has a big old shadow. And then again, we've got the umbra, which is the darker part of the shadow, and the penumbra. So a few years ago, when the eclipse happened, if you were somewhere along the path of totality, they call it, you saw a total solar eclipse, then you were in the umbra. Here, if you stayed here and didn't go somewhere, you would have been in the penumbra, and you'd have seen a partial solar eclipse. Okay, there you go. Little tiny spot. See the penumbra or the umbra is the darker part of the shadow. Just a little swath. Only lasts a few minutes at a time. The lunar eclipse can last hours and hours, and might look a little red. So there's a couple of videos in here. If you want to watch about the solar eclipse, you can. This PowerPoint is in the OneNote. We're not going to watch it right now. Then there's the lunar eclipse video. Watch about that also. So I guess maybe I didn't say. Hold on. Obviously, then the lunar eclipse has to happen at midnight, or not at midnight, but on the full moon, right? That has to be on that side of the Earth. Okay. So one of the reasons why the solar eclipse is so exciting, it's right in the middle of the day. The sun is at its highest, brightest point, and then the moon goes in front and blocks it out, and it is dark for several minutes at a time, like it's nighttime, to get this kind of eerie glow happening. Really cool. 100% recommend. 2024. Figure out where it's going to be. Um, the total solar eclipse. Okay, so we don't have to do that. We would talk about planets a little bit because next we can do the solar system gizmo. Week. That's really easy. Planets. So then we would finish the night with this. So these will be in the OneNote. This will be in the email as well that I send you. Just look at 4 other classmates' sparks. So it'll be in the OneNote. It's going to look like this. Everybody's sparks will be listed there, and then there'll be this little critique. So you just have to look at any 4 that you want that aren't yours, and then critique them based on this sheet here. There's 4 of them on this document, so you can do any 4 you want and just email those to me. So it says on there, tonight by 8 p.m. That was if we were having class. Officially, we're not having class. So, just as soon as you can get them within the next few days, we'll say those critique sheets to me. Okay. So today is the 18th, right? So next week, next Thursday, planning to not meet, but it was optional. So the week after is the astronomy quiz. So if you wanted to look ahead at the seasons things and come in and ask questions next week, optionally, I'll probably send out an email and see if anybody actually wants to meet. If nobody wants to, we won't have any meeting at all. If you don't want to, you don't have to. If you have questions, you can. So if you have questions then about the moon stuff that we just went over now, also, since we missed that because of the snow, you can optionally meet for that to ask some questions before the quiz if you need to. Okay. So let me know if you got any questions, and we'll talk to you soon.